All right, so hi. Today's objective, we're going to move into pOH as well. And so for pre-AP, this is just my review of yesterday's lecture. And for regular, this is like brand new day for us on Thursday. However, both same content. So let's review some things here. First and foremost, pH. So fun fact, this P stands for potential. So it means literally the potential of hydrogen ion concentration. So notice pH here, and this is used to determine hydrogen ion concentration. Okay, that's what the pH scale tells us. And let's just review the pH scale briefly here. So this is my scale. What does it go from? 0 to 14. What's in the middle? What's considered neutral? 7. Great. What is considered acidic? This side or this side? This side is considered acidic. So lower numbers are considered acidic. Higher numbers are considered basic. And obviously this is neutral, right? So just as a brief reminder here, from like the 1 to 3 area is considered like a strong acid area. And then for the opposite side, so from like the 12 to 14 area is considered a strong base. Okay, so let's just review that. Also, like really quickly, what those two things mean. So what makes something a strong acid is that they break apart easily. So I'm just going to abbreviate here. That means strong acid. So strong acid is that they break apart, or these compounds break apart easily. The vocab word for that, guys, is dissociate. So that just means come apart. And then same goes for strong bases. The same thing happens. They also break apart easily. Weak acids and bases do not break apart easily. It's only like part of them break apart and the rest do not. Okay. Okay, so here's what we're focusing on a little bit more today that I told pre-AP that I would review with you a little bit better because there are some extra steps for some of these. So pOH is the concentration of hydroxide ions. And remember that hydroxide is known as OH negative. It is a polyatomic ion, okay? So formulas. And we'll do it in blue because it's like more of, it's a descriptor of like basic solutions. So formula, we have pOH equals, notice it's the exact same thing as hydrogen ions, right? So negative log of OH, or we could do the pOH equals 14 minus pH, okay? So, review of those. So, just for the relationship aspect between the pH and the pOH scale, guys, it's literally the same scale, just opposite. And it makes sense, right? So, let's go over these rules really quick. So, the rules is if there is a high hydrogen concentration, that means that there's a low hydroxide concentration, right? And the same goes as if I were to flip these two. So if there's a low hydrogen ion concentration, there is a high hydroxide concentration, right? And then let's just review here. Remember, because the pH scale is literally telling us the potential of hydrogen ion concentration. And the pOH is telling us the potential of hydroxide ion concentration. So if I have a high amount of hydrogen ions, that is a more acidic solution. And therefore the opposite. The opposite is also true. So high hydroxide would be basic. Okay, but notice that if it's high hydroxide, that means that it's also, let's make a note here, a low of hydrogen. These words are so close together and I can't say them today. Okay, so if it's a low hydrogen ion concentration, it has a high hydroxide concentration, and therefore it's considered basic. So just note these relationships here, and that's what we're focusing on. So as for an example of how to calculate pOH versus pH, or maybe there's like, oops, way to knock my phone over. Or maybe there's a two-step problem that you might need to do depending on the information that they give you. So let's look at this first example. So first example, what is the pOH of a 0.00063 molarity HCl solution? Okay, so notice we're given, just like we did before, we're given something with molarity. So that right off the bat would tell me that this is some kind of concentration. And remember that the brackets, guys, like these little brackets around the letters here, that means concentration in science language, okay? So, being that I have a concentration and it wants me to find the pOH, then that means that I just need to plug it into my formula, right? So, pOH, negative log, and we're just going to plug in this number, right? 0.063. Okay, so when I plug that into my calculator, we get a pOH of 3.2 or 3.20. So if it's 3.2, that is a low pH, a low pOH, which means that this actually, so let's calculate, I want you to see this relationship really quick. So that would mean that if I were to try to find the pH from this, I could just use this other formula here, right? So the other formula that we have is pOH equals 14 minus pH. So say that I wanted to calculate the pH with this information, then I would just do pH equals 14 minus the pOH, which would be 14 minus 3.2, which is what? 10.8. So according to the pH is high, but notice that the pOH is low, right? So this is actually a basic solution. So notice the difference. Okay, notice the relationship of pH and pOH. When one is low, the other is high, and vice versa. Okay, so as for your practice for today, you are still using mainly this formula to calculate pOH if I give you a concentration. However, I do want to point out, what if there's a problem? Let me open it up here. What if there's a problem that involves two different steps? Sorry, I'm opening up practice, and especially for pre-AP, pay attention here because this will help you on some of the questions that I have a feeling you might have. So this one is, so at this point, regular chem, you can go ahead and get to your practice for today, but you are practicing calculating pOH and then just identifying, like, okay, is it acidic or basic? When one is low and one is high. I just wanted you to understand that relationship here, okay? So you can stop watching at this time. Pre-AP, so this is in regards to your practice, which is day 2 of calculating pH and pOH, right? So, for example, slide 5. So this is slide 5 on your practice. So this one says, what is the pH of a 6.50 times 10 to the negative 3 molar KOH solution? So, and my hint says, notice because of the OH, this is a basic solution, which means that this concentration is actually OH. Okay, so I am given the hydroxide ion concentration. So there's a few steps that I need to take here. So first things first, I I want to get to pH, but I'm given this. So can I just put the negative log of that and that's going to be my pH? No. Okay. I first need to calculate pOH. It's almost like a puzzle because you can only notice our formula says pOH equals negative log of this concentration, which means this is a two-step problem, right? So number one, we need to calculate pOH. So pOH is the negative log of that number, 6.5 times 10 to the negative 3 molarity. So when I put that into my calculator here, let me do that really quick. So we do negative log of 6.5 times 10 to the negative 3, close. We get 2.2 about, so our pOH is about 2.2, right? But I don't want pOH, I want pH. So how can I get that? There's a second step, and I just use the other formula because remember, the magic number is 14 because that's what the pH scale and pOH scale go to, from 0 to 14. So I'm going to use the pH formula that we learned yesterday. So pH equals 14 minus pOH. And so then I'm going to do 14 minus 2.2. And when I do that, 14 minus 2.2. I can't talk today. 11.8. So then this is what answers the question. It's high pH. So if it's a high pH, acidic or basic, which makes sense because this is a basic solution, right? So just keep that in mind. And I gave you hints like if it's a basic or acidic solution. And it's kind of like a two-step problem, but it's an easy two-step problem, right? So hopefully that helps out your confusion for today's practice and maybe even yesterday. So after doing this, go back and correct anything that maybe you did not do correctly on yesterday's practice, okay? That I told you I would explain today. Hopefully that is helpful to all of you. If not, it takes practice. But honestly, guys, these formulas are not necessarily hard, and that's thanks to the fact that we have calculators, okay? So feel free to email me with your questions, and I hope you have a great day.